All right, in this video, we are going to look at graphing a linear equation using a t-table. So here I've got my x's and y's. These are like my inputs, and these are going to be the corresponding outputs over here. This method is kind of cavemanish. It's really inefficient, but people use it, and it works for other equations too. If you wanted to graph bigger ones, which we'll talk about some other day, but you got exponentials, uh, cubics, whatever. This method will work for a lot of stuff. Anyway, so what we're going to do is we're gonna plug in -1 for x and see what y value that gives us back. So it's going to be y equals 3 -1 plus 2. 3 times -1 is equal to -3. And then -3 plus 2 is equal to -1. So we get y equals -1. All right, when you plug in -1 for x, you get -1 back. Let's plug in 0 for x. 3 times 0 is 0. 0 plus 2 is equal to 2. So you get y equals 2. Plug in 1 for x. 3 times 1 is 3, plus 2 is 5. Plug in 2 for x. 3 times 2 is 6. 6 plus 2 is 8. I'm probably not going to use that one. But what these are ordered pairs. All right, so like -1 comma -1 is going to be on the graph of this line. 0 comma 2 is going to be on the graph. 1 comma 5 is going to be on the graph. So I'm going to plot these points, and it's going to make a nice pretty line. Let's do 0 comma 2. So 0 for x, go up to 2 on the y. That'll work right there. -1, -1. So -1 for x, -1 for y. It's going to be about right there. And let's do 1 comma 5. That'll be enough. 1 for x, and then 5 up. 1, 2, 3, 4, 5. I guess I can go ahead and do this one. So 2 for x and 8 for y. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. It's a lot better when you have grid paper, but you don't even have to do these little tick marks. I don't care that much about it whenever I go to graph it. So I've got my points plotted, and I'm going to go ahead and try to draw a straight line here. It doesn't really matter that much. That'll work. Okay. So this is supposed to be infinitely small or infinitely thin, but this will work. So we made a t-table just choosing values for x. I chose values that were close to 0. Normally you do that. And then we plugged -1 in for x, and it gave us -1 back. We plugged in 0 for x, and it gave us 2 back for y. So these are our ordered pairs. Now, normally, you know how regular equations, like two-step equations, 3x plus 2 equals 8 or whatever, this will only have one solution because it's a degree 1 equation. Well, when you have linear equations with two variables, x and y, you end up with infinitely many solutions. So any point that is on this line, let's say it's -2 for x. Let me figure out what this is going to be. -2 for x and -4 for y. So -2, -4. That will be a solution for this equation. Okay. Another thing I want to point out here, and this is not going to be our main method for graphing stuff. I'll have you do it a little bit, but not too much. Is I want to point out what the slope is, the slope of this line. So let's look at this point and that point. So count how many units it is up. Yeah, I think that's supposed to be closer to that spot right there. 1, 2, 3 units up and 1 unit over. So it's 3 up and 1 over, and that's the slope of this line. Notice that that's that number connected to the x there. That will always be the case. This is in slope-intercept form, which we'll talk about in the next video. Let me see how I'm doing on time real quick. Used up all of our time. I'm gonna do one more example here. All right, I'll make a t-table. X, Y. I'm gonna do even numbers this time. -2, 0, 2, and 4. The reason I'm doing even numbers is because I'm halving it. So let's plug in -2 for x. So you'd have -1/2 times -2. Well, a negative and a negative is positive. So now you're going to think of 1/2 times 2. Well, 1/2 of 2 is equal to 1. And then 1 minus 4, -3. Now plug in 0 for x. -1/2 times 0 is 0. 0 minus 4 is -4. Let's plug in 2 for x. -1/2 times 2 is -1. Minus 4 is equal to -5. Hopefully you see my pattern here. As we go up by 2, these are going down by 1. So I'm guessing my next one's going to be -6. Let's plug in 4 for x. All right, -1/2 times 4. That's half of 4, so that's going to be -2 minus 4. That's -6. All right, now these are my ordered pairs. So let me plot those. So -2, -3. That's left 2, down 3, somewhere in that neighborhood. Oh. Okay. 0, -4. 0 to the left and right. And down 4, something like that. 2, -5. So that's 2 to the right. And then down 5. Somewhere in that neighborhood. 2 to the right and down 5. And then 4, -6. About there for 4. And this would be -6 somewhere in there. Yeah. Probably didn't draw it too accurate. I didn't do too bad. You can see the lines, they are all on the same line. The points are on the same line here. So if we connect those dots, again, any point that's on this line is going to be a solution to this equation up here. So when you plug in 4 for x, you will get -6 back for y, so it is a solution. Again, notice that the slope is this number here, -1/2. So from point to point, we're going down 1 and over 2. We're going down 1 and over 2. All right, that's always going to be your slope there. And notice this number. I didn't mention that on the last one. This -4 here corresponds to that -4 there on the y-axis. That's always going to be your y-intercept. I'll mention that more in the next video.